project look like this. So the cat's first, the cat starts at the center of the stage, then it moves right. As soon as it hits the wall, it moves left, then right again. And we see the costume change for the cat as well, which is we pretend that represents the cat walking. So in order to make this effect, we used a few blocks in the motion category. First, we can have a look at this script here. As soon as the green flag is clicked, the first thing the cat does is it goes to the center of the stage. So this is represented by the instruction, by the block, go to X something, Y something. And since it has to do with the cat going somewhere, this block is put in the motion tab. So you can see the block that says go to X something, Y something. These two little circles here, these are text boxes for you to type where you want the cat to go. So the two numbers here, as we mentioned last week, are distances from the center. So the number after X is how far left or right it is from the center. So if the X value is positive, if it's greater than 0, then the position is right of the center. It's on the right side of the stage. And if this X value is negative, if it's less than 0, for example, if it has a minus sign on the front, then it means that the position is on the left side of the stage, that it is left of the center. And something similar happens with the Y value. So the Y value specifies how far up or down the cat is from the center. If the Y value is greater than 0, then the cat is on the upper half of the stage. And if it's less than 0, the cat, the position is on the lower side of the stage. So, and if we set both X and Y to 0, so that means we're going to want the cat to go to exactly the center. We can test this by clicking on the block, which tells the block to run. And the cat does what we expect it to do. It goes to the center of the stage. We have a couple more motion blocks after this. We used the point in direction block and the set rotation style block. These two are also in the motion tab. So the point in direction block, can anyone tell me what that does? Take a guess. This block tells the cat to point in a specific direction. So if this is 90, then that means to the right. So yes, so 90 degrees means to the right, 0 degrees means up, minus 90 degrees means left, and 180 degrees means down. So when we tell the cat to point in direction 90 at the start of the script, what we're telling it to do is to face right. And then we have the block set rotation style left to right, which tells the cat that when it rotates, instead of actually turning, it's going to flip left to right. So without the rotation style set to left to right, if it's set to all around, for example, then the cat would be able to face any direction. But if it's left to right, then it will only face right or left. And we want to set this to left to right because the cat will we will want the cat to turn whenever it hits the corner of the stage, and we don't want the cat to flip around, to flip upside down. We only want it to flip left to right. So these three blocks are the ones we've seen so far, and then we get to what we call a loop, which is basically something that tells Scratch to run a set of blocks over and over again. So this is the one we're using is called a forever loop, which tells the cat to run a set of instructions infinitely many times, well, forever. So this block is found in the Control tab, which is the orange circle at the left side of the screen. It's the third block from the top. It looks like this. And by itself, it doesn't do anything. But if we put a block in it, then it will continuously run that block. And as you can see here, we can also put more than one block in it. And if that happens, the forever loop will run the blocks in order and then repeat again. So in this forever loop, what we're telling the cat to do is to first move 10 steps to the right, and then it switches its costume. This cat has a total of 2 costumes. One looks like this, and the other costume looks like this. And if we switch costumes over and over again, it can look like the cat is walking, not just sliding around. So we tell the cat to switch costume and move 10 steps to the right or to the left. Here, move 10 steps basically tells it to move in the direction it's currently facing. So the cat moves 10 steps in its current direction, and then it changes its costume. And then we get to the if on edge bounce block. This block is colored blue, and so we find it in the motion tab. And it tells the cat to sense whether it's on the border, whether it's on the edge of the stage, and if it is, it will turn around. So this block tells the cat to turn around whenever it hits a corner, and then it waits 0.1 seconds to make sure it isn't walking too quickly. And after these 4 blocks are run in order, they are run again from the start and then repeated. This is because, as we mentioned before, they are part of a forever loop. So this was our complete script for last week. And if we try running it by clicking on the green flag button, we will see that it works as we expected it to. So that was pretty much our project for last week. Just a bit of review. The characters in Scratch are called sprites. So in this project here, we have one sprite, which is the cat. For today's project, we're going to have a few more sprites in our project. And then if you were looking for the project that you made individually last week, if you were here, here's how you do it. You go to the Scratch website. Just going to type it here. Scratch.mit.edu. First, to make sure that you're logged into your account. And then when you are logged in, you can click on the folder button at the top right corner of the screen, and that will take you to all your projects you have. And you can click on the one that's you did last week, and that's how you revisit it. It will take you to a page that looks like this, and you just have to click See Inside to see all your code. That's the blue button at the top right corner. But today, for our projects, we aren't going to need our code from last week. We're going to be starting a new project. But before we do that, some introduction. So today we're going to focus on the topic of video games. Last week we made a pretty basic animation, but we also looked at a video game that people have made. And so this week we're going to focus on actually creating something that we can call a video game. And specifically, we're going to look at how we can control a character based on the player's inputs, which is usually the keyboard or the mouse. And then we're going to add more sprites to our project. And we're going to see how we can make them interact with each other. And finally, if we have time, we're going to look at how we can make things happen randomly. Games are always exciting when there are some elements of randomness in them. So we're going to look at a bit of that this week, if we have time. All right. So I'm going to show you a video game that I found before this class. If you remember the last one that I showed you, which was last week, that one was really well designed, and it's also very smooth and flows pretty well. This one is also very well. It took someone a long time to design this, and it actually took multiple people to finish writing the code for this project. It was a collaboration. So let's have a look. So if you remember the project that we looked at last week, it was a two-dimensional project. It was a platformer that had the player navigating obstacles. And this project is something similar, except it's in 3 dimensions. You can look left or right with the arrow keys. You can also look up or down. And you can make the characters move in all 4 directions, and up and down. And as you can see here, the character is also pretty neatly animated. Obviously, it took someone a long time to come up with this. So we can make the character move in the direction it's pointing in, and in the other 3 directions. And the objective of the game is pretty clear. It's to follow the path and get as many coins as possible. So we start playing the game. And there's actually a score counter that shows up on the stage, and it will count how many coins that the player collected. And that is also part of the game's objective. And we get to here. Let's see what happens here. And then that's the end of the game. So a few things that we notice with these video games. First of all, they're for fun. This video game here is a bit short to actually like, in itself be fun. But this game can be used as a template or as a starting point for other projects. And as we will see later, that is a very common way in which a very complicated projects in Scratch get made. So basically, this project is not meant as itself to be played as an actual game, but as a template for other game developers to build on. But that said, most video games are for fun. And another thing we notice is that the player can control the game. In this game, the controls are using keyboards, using a keyboard. And finally, the player gets to see how the game responds. And these two elements, the player control and feedback, are pretty crucial to making sure that the game is actually fun to play. And if we look closer at how the player actually plays the game, there is the main character. It's this. Here it's called a fox. It might be anything else. And the character is controlled by the player. So if we go back to the game, the player controls which direction the character looks and which direction it goes in. So the character behaves pretty predictably. The player can always predict how the character will behave if the player does a certain action. But the character also interacts. It meets and its affects and is affected by the surroundings of the character and potentially other characters in the game. So in this game, like many other platformers, there's an opponent in the game. But for platformers, the opponent is the character's surroundings. The character needs to know how to get past them. But in other video games, the opponents might be other actual characters as well. So, and in order to make the game fun, the opponents, the other characters, have to make sure that the other characters need to behave unpredictably. So, for example, in this game, we know how the character will behave if we press the keyboard, but the player doesn't know what the terrain will look like after they cross this turn. And if they're playing the game for the first time and they get to, say, right after here, if they get to this part and they see this orange block, they will not know how to what exactly it does, and they can only know how the surroundings interact with them once they try it. So to recap, in almost all video games, in order to make the game interesting, there is a main character that's controlled by the player pretty directly. And how the main character gets controlled affects its interactions with the surroundings or with other characters. And when the surroundings with the other characters, which might be opponents, that's the opponents or obstacles that the character is trying to get around. When these opponents or obstacles behave unpredictably, that's what makes the game interesting and fun to play. So, you might be wondering why we're discussing these. That's because we're going to use them in our project for today. So it looks like this. So right when the player starts playing the game, the player knows which one is the player character and which one is the opponent. The player can control the player character using the arrow keys. And since it moves so predictably, the player will know that this is the character that they're controlling. And obviously, this character here, this butterfly, is the opponent. When the player presses the spacebar on their keyboard, this player character fires a soccer ball or a beach ball. So the objective is to try to hit the butterfly. When the player hits the butterfly says out. And when the player doesn't hit the butterfly, the ball goes to the other side of the wall. The ball goes to the other side of the stage. And if we have a look at how that butterfly is moving, it's always rotating. It goes from sometimes the top of the stage, sometimes the middle of the stage, to the bottom of the stage. So it moves quite unpredictably. But it's still possible for the player to get the butterfly. So before we start, does anyone have any questions? All right, then we can get started. So first of all, we're going to unlearn a new part of the Scratch of the Scratch interface. And Eric, do you have a question? No? Okay. Okay, got it. So today we're going to learn how to use the Sprites panel, which is the part of the interface. It's part of the Scratch editor, and we have it at the bottom right corner. It's this rectangle here. So right now, in the finished project, we can see that we have 3 sprites. They each represent the player character, the balls that the player can fire, and the butterfly. So let's make a new project. And we're going to learn how to create this game. So if we have our brand new project, we can see that in the Sprites panel here, there is our built-in sprite, the cat. And today we're not going to use the cat, so we're going to delete the sprite. And how do we delete it? We make sure that the cat is selected, and then we press the button that looks like a blue garbage can. That's at the top right corner of the small picture of the sprite, right here. So Now, what do you think will happen if we press this button? Ryan?
It likes deletes it.
Yes. So pressing this button deletes the sprite. And now we have no sprites in the Sprites panel, and there's nothing on the stage. So we're going to start with the player character, which is the character that the player controls. So how do we add characters to Scratch? Well, there are a few ways. We can use a character that's built into Scratch. As we're going to see, Scratch has many characters or pictures that they have ready for us. And we can also create a sprite or upload a sprite, but we're going to learn how to use those later. So first, we're going to have a look at the bottom right corner of the Scratch editor. So we see two buttons. There's a blue button that's labeled Choose a Sprite, and that looks like the head of a cat. And then there's a blue button called Choose a Backdrop, which is it has an icon like a photo. So this button, the Choose a Backdrop button, changes the look of the stage, and the Choose a Sprite button adds a new sprite to the Sprites panel. So this Choose a Sprite button is the one that we're going to use today. So first of all, let's click on this button. And we're going to see that Scratch gives us all this range of pictures and characters. We're going to choose the character that we're going to use here. And so we can look for it here. So the character that we are using is called Chico Walking. If you can't find it, you can also click on the search bar that's on the top left corner and type Pico Walking. Once we have this character, we can put our mouse over it to preview all the costumes that it has, and we can click there to add the character to our Sprites panel. So now we have the Pico Walking sprite in our Sprites panel. And we can also see it on our stage here. So every sprite that shows up here will probably also show up on the stage somewhere. And we can drag it around. We can put it right here. So we're going to have another look at how the character here behaves. When the player presses the down button, it moves down. And when the player presses the up arrow button, it moves up. So we're going to figure out how this works. And so we're probably going to need to a block in the motion tab that controls how the sprite moves. And also, we're going to need a block that's like the when we say click block here, but instead of running a script when the green flag is clicked, we want a block that runs the script when the arrow keys are pressed. So the block for that is also in the yellow Events tab on the left side of the screen. So here we see the when green flag clicks block, and right under that we see the when space key pressed block. So this is the block that we're looking for. But instead of listening to when the space key is pressed, we're going to change it so that it listens to the arrow keys instead. So we have a bunch of options, all the keys on the keyboard, and we're going to do up arrow first. So we have this block. And now it says when up arrow key pressed. So when the up arrow key is pressed, we want the character to move up. And if we go back to the motion tab, we might be tempted to use the move 10 steps block, but remember that this block only moves the character in the direction it's currently pointing in. So this would move it right. And if we change this to -10, it will move to the left. But if the character is facing to the right, no matter what number we put in here, we're not going to make the character move up. And if we have a look at our finished project here, the character is always pointing to the right, but it's moving up and down at the same time. So that means we can't use the move steps block. We're going to have to use another block. And the one of the other motion blocks that we learned is the go to X, Y block, which tells the sprite to go to a particular place on the stage. So X is how far it is left or right of the center, and Y is how far it is up or down from the center. But that tells the sprite to go to a particular place, but we want it to move up or down relative to its current position. But if we want it to move up or down, we can simply use, change the Y value. And there's actually a block for that in Scratch. So it's also in the motion tab. If we scroll down to near the bottom, we can see 4 blocks. One's change X by something, one's set X to something, one's change Y by something, and one's set Y to something. And if we remember, the Y value is how far it is up or down, and we want it to move up and down. So it makes sense to use the change Y by block. And as we see here, that definitely works. So change Y by 10 tells the sprite to move 10 up, and change Y by -10 tells the sprite to move 10 down. So we're going to get rid of this block and snap the change Y by 10 or -10 block to the when up arrow key pressed. And we want it to move up, so that should be 10. So let's test this. And for this to work, we don't actually have to press the green flag button. We only have to press the up arrow button. And it does make the sprite move up. And we want it to move down as well. So we do something similar. We go back to the Events tab, which is the yellow circle, and we drag one of the when space key pressed blocks into the script area. But instead of space key, this time we're going to choose down arrow. And similarly, we can go to the blue motion tab and scroll down. We see the change Y by 10 block. But instead of 10 this time, we're going to make it -10, which means down. So up changes y by 10, and down changes y by -10. And we can test that by simply pressing the up and down buttons on our keyboard. And indeed, that makes the character move up and down. If we have another look at this project here, the character is also changing costumes when it's moving up or down. And we learned how to do that in our first project. We simply use the next costume button in the next tab. So that's what we do here as well. But instead of setting the change costume block in a forever loop, we're only going to change costume when the keys are pressed. So we go to the purple looks tab, and like we did last week, we find the next costume block, which is right in the middle of the window. If we try clicking it, we see that this character switches between 3 different costumes. One looks like this, one looks like this, and one looks like this. We can save 2 of these into our script area. One of these goes here, and one goes here. So we change the costume both when it's going up and when it's going down. That looks pretty well. That looks pretty good. And now we're going to make it fire the ball, the beach ball. To do this, we're actually going to have to make another sprite. We're going to have to add another sprite to our project. And this sprite is also built into Scratch. If we look at the bottom right corner of the screen again and find the Choose a Sprite button, the cat head button, we can see quite a few objects: the ball, baseball, basketball, beach ball. We're going to use beach ball. So we click on it, and it's here. The beach ball looks a bit too big, so we're going to scale it down. We're going to make it smaller. How do we do that? Well, if we look at this section, we're going to find a text box that's labeled size. So currently the size is 100%. If we want to make it smaller, we decrease the size. So let's make it something like 50%. That looks better. And right. So if we have another look at this, the ball is going to be fired when the character, when the player presses the space bar. So whenever the space bar is pressed, the ball starts at a character and moves right. So first, we're going to make sure that we select the ball. And then we're going to have the script for the ball, which is currently blank. So we're going to make the ball do something whenever the space bar is pressed, the space key on the keyboard. So we're going to use the same block as this, but instead we're going to select space. Oh, and space is already selected. So that's good. So we have this block. And when the space key is pressed, we want the character to kick the ball. How do we do that? Well, first, we need to make sure that the ball is at the character. we need to make sure that the ball goes to the player whenever the space key is pressed, because the ball is going to move, it's going to go to the right, and if it doesn't start back at the player whenever the space key is pressed, it's going to be a bit weird. We want it to seem like the player is kicking the ball. So whenever the space key is pressed, we want it to go to the character. And if we want to, if we want it to go somewhere, then we're probably going to use a block in the motion tab. And we see 4 blocks down from the top. We see the go to blocks. Here it says go to a random position, but this is a drop down menu. And we can select where we want it to go to. The options are random position, mouse pointer, and Pico locking. And Pico locking is the name of our main character, so that's what we want here. When the space key is pressed, we want it to go to Pico locking. But we don't want it to just go there and stay there. We want it to move to the right whenever the space key is pressed. So here's what we do. If you remember the forever loop that we visited last week, that makes the character repeat a certain number of instructions, and we want to make the ball repeatedly go to the right. But we don't want to keep going to the right forever. We want it to go to the right until it hits either the butterfly or the right side of the stage, and then we want it to stop. So it's still going to be called a loop, but it's not a forever loop. If we go to the Control tab, which is the orange circle, and we scroll to the bottom, we're going to find a loop that says repeat until. And it looks pretty similar. It has a similar shape to the forever loop. But if we look carefully, there's a vent at the top. There, as we saw with the forever loop. But there's also a bump at the bottom, which we don't see on the forever loop. Well, the key difference is in the forever loop, it repeats a certain number of instructions, well, forever, so it doesn't get to finish. But the repeat until loop, this loop might finish. And when it finishes, we might want it to continue running some blocks. So that's why it has both a dent at the top and a bump at the bottom. And there's we see a weird shaped slot right after the text repeat until. That's a slot for something that we call a Boolean value. I'm going to write this. It's spelled here, like this. And it's basically this basically means a yes or no value. So a yes value is expressed as true, and a no value is false. And blocks that give a Boolean value, which means a yes or no value, always look like this. So it's shaped like this, like this hexagon. So if we So right here, we don't currently have a butterfly sprite. We're going to add next class, but right now we wanted to sense when it hits the right side of the stage, and we wanted to stop moving to the right when it does that. So we're going to have a look at a brand new tab that we haven't looked at last week. It's called the Sensing tab, and it's this light blue turquoise circle at the left side of the screen. And right at the top, we have a block that's shaped like this. It's shaped like a hexagon, and it looks like it might fit into this slot. Let's test it. This block is called touching mouse pointer, and we can change the mouse pointer to edge. If we have a closer look at this block, what are the possible values that we can get from this block? Well, it's either a yes, the character is touching the edge, or no, the character isn't touching the edge. So this character gives a yes or no value, which is a Boolean value. And the repeat until block also wants a Boolean value because it repeats this whatever instructions it has here over and over until something here becomes yes. And this is what we want. Whenever touching edge is no, it repeats this instructions that tells it to move right over and over. But as soon as touching the edge becomes yes, which means it is touching the edge, the ball stops repeating the move right instruction. So we know that this is the block that we want, and we snap it into this hexagon slot here. And we snap this right here. So right now we have this with space key pressed, go to people walking, and repeat until touching the edge. What do? We move right. So we could use the move 10 steps block, but if you saw here, the ball also spins. And if we try to make it move 10 steps while it's spinning, it's going to move in a spiral, and we don't want that. So we're not going to use the move 10 steps block because we only want it to move right, and the ball is going to be rotating in every direction. We saw the change y by block earlier. There is also a change x by block, and as you might have predicted, this makes the character go to the right or left if this number is negative, and it's less than 0. So this is the block we want. It tells the sprite to move right. Let's call it 5, change x by 5. And then we snap this into the repeat until block. And finally, well, first of all, let's just test this. With the space key is pressed, it goes to people walking, and until it touches the edge, it moves 5 steps to the right. And we want it to rotate as well. So we're going to learn yet another block, yet another new block. It's in the motion tab because rotating is a kind of movement. And right at the top, we see 2 blocks. Turn clockwise and turn counterclockwise. You can use either of these blocks. I'm going to use the turn clockwise block. And I'm going to put it right after the change x by block, which tells it to move right. So here, the turn clockwise block tells it to turn clockwise. And 15 degrees is too much for one turn because we want it to look smoother. So we turn less at a time. They said it's 5 degrees. And when we press the spacebar, it turns. Well, actually, I'm going to make it 50 degrees anyway, because that looks better. All right. And one more thing that we noticed about the ball. Here, the ball disappears as soon as it touches either the butterfly or the wall. But here, it doesn't. So we want the ball to be seen only when it's flying through the air, not when it hits the butterfly or the wall. Well, there is actually a way that you can make a sprite not be seen on the stage. There's if you look at the Sprites panel at the lower right side of the stage, of the Scratch editor, there are two buttons labeled Show. So this button means Show, and this button means Hide. And if the Hide button is selected, then the beach ball isn't shown on the stage, which is what we want when the ball isn't flying. And in the next tab, there will also be blocks that control whether the sprite is shown or hidden on the stage. If we go to the purple looks tab and we scroll all the way to the bottom, we're going to see two blocks, show and hide. Show shows the sprite and hide hides it. So we can do something like this. When that space key is pressed, show, then go to people login and repeat this. And finally, when touching edge becomes yes, it stops repeating these and it goes to here. And after it stops repeating these, we want it to hide itself. So this is what happens when the player presses the space button. The BeatFall shows, slides, then once it hits the wall, hides. And one more thing, we want the BeatFall to be hidden whenever we press the green flag, which means we start the game. So to do that, we're going to create one last script in the BeatFall sprite. We're going to go to the events tab, and we're going to drag and drop that when green flag clicks block, which as we saw last week, responds to the green flag being pressed. So when the green flag is pressed, a pretty simple script, we want it to hide. So the ball hides when the green flag is pressed. And when the space key is pressed, it shows, goes to the right, and hits the wall. One final thing. If we press the space bar and we move the sprite, the ball isn't going to follow the sprite. It's going to keep moving on its own because we didn't tell it to move with the sprite as it's flying through the air. It only goes to the sprite once when the space key is pressed. So that's pretty much all the code we're going to write for this lesson. We're going to review some of the blocks that we learned and concepts as well. So starting with the Sprites panel. So the Sprites panel contains all the sprites that we have in the project. Some of them might be shown on the stage, some of them might be hidden. And each sprite has its own set of instructions, its own set of code. And if we click between different sprites in the Sprites panel, it's going to show us different code. And we can also add sprites to the Sprites panel. Can anyone remind me of how to do that? Well, we use the Choose a Sprite button. And we can see all the sprites that Scratch has ready for us. And once we have all the sprites we want, we can begin programming them. The first thing we learned was how to make the scripts respond to the keyboards. We learned this block in the Events tab called When Something Key Pressed. And the key can be any key on the keyboard. We learned the two blocks, change X by and change Y by, and how they make the sprite go left or right, or up or down. And we learned how to show and hide a sprite, both using the blocks in the code and using the show or hide buttons here. We learned how to make a sprite go to another sprite. We learned the repeat until block, which repeats a set of instructions until a certain yes or no value, called a Boolean value, becomes true or yes. And we learned one block in a new tab, the sensing tab, which is the touching something block. And the something can be mouse pointer, edge, or another sprite, like our main sprite here. And that is pretty much everything that we're going to cover in this class. Next class, we're going to resume everything that we looked at. We're going to resume this project next class. And in the weeks after that, we're going to have a look at a new project. And I realize that for some of you, you might have seen this before. This is hopefully it's a good bit of review, and hopefully we've also covered something new this class that you haven't learned before or that you've forgotten. So if you want to have a look at our project after class, it's always available on Scratch. I will name this project and share with you. So here it is. It's in the chat. So you can refer to this if you have any questions or if you want to revisit the project. And if you come up with any questions, feel free to send me an email at the address that I've shown here. And that's it for our lesson this week. See you next week, next Friday at 7:30 p.m. Bye.